In question number 1 of chapter 39, we are required to find the time required for a 50 Hz alternating current to change its value from 0 to RMS value. So let's first draw a picture of how does a AC current looks like. So this is the time and this is voltage, and this voltage starts and it varies something like this. It can keep going on, and the RMS value is somewhere here later, and let's say this is the max value of this voltage. We call it V max, and then this is somewhere the RMS value, Vrms. Now this voltage, this varying voltage, can be represented as V is equal to V max multiplied by sine 2 pi f into t, where f is the frequency of this signal. The RMS value, Vrms value, is defined as V max divided by square root of 2. If you forget this thing, you can derive it using Vrms. What is Vrms? The root of mean square. How do you find the mean square? Mean square is, you first square it. So you write V max square sine square 2 pi f into t, or maybe cos square 2 pi f into dt. dt integrated from 0 to maybe 0 to pi or 0 to 2 pi, whichever you like, and then divide the whole thing with this whole duration 2 pi. So if you forget this Vrms formula, you can derive it, apply the formula for sine square theta in terms of cos 2 theta, and then find this value. So you will get this. Finally you should get it. Now in this one we are required to know when this value of V is the same as, it starts from here 0, keep rising. We need to find out at what value of time t is this value of V is equal to the RMS value. So what we need to write? We will write V as equal to Vrms, which is V max divided by square root of 2 is equal to sine 2 pi f into t. Now there are several values of t where V, with this value V becomes equal to V max. For example, it equals to here, there is one value at here, another value at here, another value at here, and at many other places. But the first, let's take at only the very first value. In that very first value, that will happen when this thing, okay, sorry, I missed the V max here. So we have V max multiplied by sine 2 pi f into 2. V max cancel. We have V 1 by square root of 2 is equal to sine 2 pi f into t. And this happens. So let's focus on the very first t value at that point, and this we know that can be written as sine 45 degree, which will write it as sine pi by 4 is equal to sine 2 pi f into t. So this equation is satisfied for several values of t. For example, t here, t here, t here, t here. But let's go, if you take the very first value of t, in that case we will have pi by 4 is equal to 2 pi f into t. Pi cancels. So t is equal to, if you take 2f on this side, it will become 1 upon 8 into f. Now f is given as 50 Hz, 1 by 8 into 50. This is in seconds, and we can, if you want, we can convert it into millisecond as 1000 millisecond divided by 8 into 5 is 40 is 400. 0 0 0 0 is 4 into 2 8, so this is 2.5 millisecond. So this is a simple problem. Just you need to know how the alternating current can be represented in terms of voltage, and you can solve it very easily.